Well, hello everyone. My last video I made a comment about if anybody would like to see me go through this radio and do some troubleshooting on it and repair it, that I would. Well, I got a lot of responses out of that. I wasn't expecting to get a whole lot, but it was very surprising, and I even got several emails that I haven't answered yet because I have so many emails. First disclaimer, I'm going to go ahead and say I don't work on these radios. I don't care to work on these radios. If you email me about working on these radios, I may even ignore it. I don't condone using these radios. It is an export. They are shipped into the country. They are illegal to operate on 11 meters, and that's not my rules. That's our federal government rules. As a ham radio operator, you can legally use this radio if you care to do so, but you will have to do quite a bit of extensive modifications to it to get it to meet spectral purity that it needs to be done to use a radio like this. Now, this radio uses what's called an EPT 3614B board. And you can see it right down the bottom. Now, these are what's called cookie cutter radios. The manufacturer that builds these, if you look inside, you'll see there's a lot of unpopulated parts. And this radio comes in many flavors. So this radio here is AM FM. Yeah, I want to make sure I was right. AM FM. You can get this radio with the same board in it with single sideband. You can get this radio with dual finals in it. This one has a single, but you can see there's a slot here in the back for another final to be installed. If we turn it over, you can see an unpopulated area here where the second dual final would go. Being that these radios are so versatile the way that they're made, they have a lot of drawbacks to them, and one of them is spectral purity, and this is exactly why I don't care for these radios. Now, if you want to get out there and talk on multiple channels at a time, this is the radio for you. If you want to get on the air and talk and keep the airways clean, stay far away from these. I'd much rather have a good Cobra 29 or something along those lines, Cobra 25, Unidens, PC66, Cobra 148. Those was back when they made decent radios. But this stuff that's coming overseas is basically crap the way that they're built. Anyway, enough of that. I said before, you know, if you want to get into working on radios and you don't know how, before you jump into a nice brand new Kenwood 2000 or one of those $5,000 ICOM rigs, you need to know what you're doing. And this is a good platform to learn off of. Now, you will not be able to go online and find a schematic for a general AP Hill, but the Galaxy DX 33s, 44s, and so forth all use the same board. It's very close to the original board that was I think it was the 11 board. It was just a 11B board, and this board here has been copied from that 11B board. So we'll get right into it and go through it, and I'll show you the steps on how I would troubleshoot this radio. Now, the first thing I went ahead and did, I've already verified this radio has no transmit and no receive. We do have noise from the speaker, but it's not receiving any signals and it's not transmitting any signals. If you put a mic in it and you key the microphone, you'll see the green light, TX RX light, will not illuminate to red. It stays green. But you can hear a popping in the speaker when you key the microphone. Also, the meter is stuck in this. You'll find a lot of these with bad meters in them. But it does not show no indication in going into the transmit mode other than hearing the electronic switching inside. So that's telling me that it's trying to go into transmit mode, but it's not. Now, a lot of times when this happens, it's either a voltage regulator is gone or there is a problem in the phase lock loop. Now, this thing has one of the crappiest phase lock loops that's ever been built. As you can see here, it is your standard PLL chip. Under the channel selector, there's two more IC chips, and these are called Adler chips. And that is in so it can cover such a wide band. This radio goes from band A to band F. So it covers a wide spectrum. But we're going to keep it right here on band D and play around with it. So starting out with any repair, regardless of what it was, the first piece of test equipment that you want to start with is your basic sensors. That can tell you a lot about the condition and the shape of what you're going to find in the radio or any other piece of equipment that you're looking at. So sight, touch, smell, hearing will tell you a lot about what's going on. Like I said, I've already done a transmit receive test and found it to be completely dead as a doornail, although there is noise from the speaker. So the first thing you can do is, like any board that's in there, take it loose, put it aside, and just go along inside the unit and look for obvious stuff, burnt components, missing components. Like I say, you know, this was a flea market find. There's no telling what has been taken out of it. But just look for anything out of the ordinary that you think, you know, could be a suspect problem. A lot of times you might find caps have vented, or you might find transformers burn up. But regardless, just look around at anything. And one of the first things I see that I didn't like right to start with, if this cord is sitting right over here, now you see somebody has spread this coil open, and this is part of the 54 megahertz trap. So it's been spread open, so it shows more power on the watt meter. It's not that the radio's doing more power, it's just that you're letting more harmonics through, and your crazy dozy watt meter don't know the difference between what's coming out on the selected frequency regardless the other frequencies that it's generating. So it just combines all those together. The radio might not be doing but 10 watts, but it's seeing all these other harmonics, and that meter is adding all those together and showing it on the watt meter. So looking at the radio, I don't see a whole lot inside of it that has been tampered with or anything that's blown or something. Now, one thing that I did not like is, you see this great big monster diode back here. You know what this diode is for? This is a reverse protection diode. And what happens is, if you accidentally connect the red wire to ground and your ground wire to the fuse box or battery, this diode is going to conduct in the wrong direction, and what it's going to do is blow the fuse in the line cord. if someone has the correct fuse in it or if they have a fuse at all. And a lot of times the diode will short. And what it does, it stops the power right here at the power connector, so that the reverse polarity does not get inside the radio and damage components like the audio chip or blow circuit traces up going up to the off on switch. Now I've seen this many times where the diode will completely fry and be blown out of it. That's because they hooked it up wrong. They didn't know what it wrong, so they go in here and grab a bigger fuse and stuck in it, and it finally blows the diode completely out. Next thing you know, you've got components, your audio chip, several other things. I've even seen it blow the top off a PLL chip where someone had put a 35 amp fuse in. So you'll see all kinds of things like this. They put this big huge diode in here. Now, what would you rather blow up? The radio or the electrical system in your vehicle? A bigger diode is going to be able to handle a whole lot of load. So the weakest link is going to end up being these small wires that come with these things going back to your supply, especially if you had the wrong fuse in it. And those wires could, you know, overheat easily and set your vehicle on fire or damage something in your fuse panel. So no, I don't like those. I'd rather have the standard reverse protection diode in there and let it do what it's supposed to do. Now, as I'm looking through the radio, I'm looking also for any mods that has been done to it, because a lot of times people get crazy with mods and they'll do some stuff that's just god awful crazy. And we look right there. Oh, come on, focus now. You can see TR32 has been removed. This is a limiter. If this was a single sideband radio, this radio would be completely useless on single sideband, because this in a single sideband radio controls your ALC. Most of the time back near the back of the radio is another limiter that is for the automatic modulation control, and this is a 2SC945 transistor, so that would have to be replaced. And then the back, there's just a diode jumper across it, so it doesn't even have TR53 in this radio. So they came here and they snatched out TR32, which is not the way you need to run a radio. This will give you flat topping, pinched off audio, and all kinds of distortion. So next thing we would do is look at the bottom of the radio and just go through as much of this as you can, and looking for cracked solder joints, burnt traces, solder blobs, or anything that's out of the ordinary. And I can tell right here, it looks like this has been worked on before, and this is the transmit mixer over here on this side. If I turn the radio over, you see that little black IC there? It's actually a circuit board with pins on it, and it's surface mount devices on it. This is your transmit mixer. So if we turn it back over, and I'll get that back in frame, you can see there's a lot of flux around these pins. So this has been took out and either replaced or took out and tested at one time. It's hard to say if this is the original or not, but this has been worked on, and this is the onlyest thing that I've seen that is worked on. Now if you know, looking at the rest of the board, I'm not seeing this flux residue, but it's on every pin. So this has been worked on. So the very first thing that we're going to do to start looking at this radio is that we're going to check the receiver power supply rail. Now, just because we hear static, you know, and we have a green light, still doesn't mean that we don't have a problem in the receiver switching network. So as you can see right here on this schematic, we have TR36. It's a 2SA1282, and we should have somewhere around 7 to 8 volts on the collector of this transistor, and this will go on through, and this feeds our receive side the voltage that it needs to turn the receiver on. Now that transistor could be shorted, loading down the whole supply and keeping everything from working. Okay, I have power applied back to the radio, but I remounted this board to keep it from flapping around and shorting everything out, which would probably make some spectacular fireworks. But we got that out of the way, so we won't see no fireworks on that. But if you look down here in this front corner, right behind the meter, you can see 3 transistors down here. And you'll see 2 short ones. I think it's 2SC945, and then you'll see that that's 2 2SA transistors. And the one that's mounted right here, this is part of your receive power supply. So we're going to go on the other side, and we're going to find the collector, and we're going to check the voltage on it. Okay, so the point that we're going to check is right down here. We're going to go to the ground plane. Don't use your chassis when checking voltage on these radios. Always go to circuit board ground, not chassis ground. And TR37 here, so TR36 is the next transistor here, and it'll be the center pin, which is collector, and we have 8.77 volts. So we know our receive power supply rail is fine. In fact, it's real good, so there's no problem there. Alright, the next thing we're going to do is come here to our PLL. Let me get this propped up here. We're going to come right over here to our PLL, and we're going to check the voltage on pin 5 of the PLL, which is IC5. And we want to see somewhere around 7 volts, give or take a volt. Depends on how the voltage is looking over there. Again, we're going to go to circuit board ground. And we have a little over 8 volts there. So that's good. Now, this is part of the supply coming in. And if you find this here missing voltage at this point, you can go back here to C90 in the radio. And a lot of times C90 will short, and that'll cause it to lose its voltage, because you know capacitors fail all the time. Now there is a resistor in between these two. I think it's R22. I can't remember what the value is, but a lot of times too that resistor could burn out, or the resistor can change over time. That'll also not supply the voltage. Okay, so now the next thing we're going to do is check our reference oscillator, which is a 10.240 megahertz crystal. And we're not going to go to the crystal and check it. We're going to come down here to IC5, which is our PLL, and we are going to look at pin 4 for our 10.240 megahertz signal. This way we'd only have to turn the radio over to find it. And we'll go up here to the old B&K, and I'll probe pin 4. And you can see we have our 10.240 reference oscillator. So we know we have an oscillator, a reference oscillator, going into the chip. Okay, now next step we'll do is check our 16.490 mixer single, and we're going to do that here at TP1. Now, you know, I could pull up the book and go through this, but there's no need of it. It's simple enough, and if you remember these steps, you can go back and refer to the manual. So let's go back to our frequency counter, and we'll look for our 16.490 single. And it's running somewhere around 15 kilohertz, 16 kilohertz. Slowly climbs. So we are missing our mixer single. Now, when you're missing your mixer single, we then have to wonder what's going on down here in the PLL circuit. So probably what we need to do is go and check our VCO voltage and make sure we have voltage on our VCO. Alright, so what we're going to do now is take off scope, and we have our scope probe set to ×1, and we're going to come here. I think it's R74. Now guys, you know, I'm doing this live. I'm doing it without any documentation. What I'm doing is just out of my head, and what you're seeing is what I'm seeing for the first time. So we're going to come here and we're going to probe R74. There's a bare lead right here on the scope, and we're going to look for about 0.8 volts peak to peak for our VCO single. Okay, get the scope probe on there. And there sure ain't no 0.8 volts there. We have a lot of ripple, but there's nothing there. Alright, what we're going to do now is check L50 down here. And there's a bare lead on the L50. It stands right out. You can see it pretty good. And we're going to look for 2 volts peak to peak on the scope, which is also part of our PLL, our VCO lock voltage. You can see that voltage is going right off the chart. I'm on 5 volts per division, so we're up at about 7 volts peak to peak. So our VCO is running crazy. Okay, so we're back on the schematic, and you can see here this was TP3 that we checked to start with, that we had absolutely nothing. This is L18. TR26 is the VCO buffer, and TR25 is the VCO. So what we want to do, we want to go into the base of this transistor and see what kind of voltage we have. Okay, I'm trying to get everything into shot so you can see exactly what I'm doing. So I'm going to go to circuit board ground over here, and I'm going to just come right here to one of the points, and we have 0 voltage. Oh, what's this? Now that's interesting. If I touch the pin, I got 8.68 volts. If I touch anything else on the circuit trace, I have 0 voltage. They need to put this under the microscope and take a look. We may have just found our problem this easy. Okay, so let me ask you, do you see anything there that looks kind of strange? Look at it real good. Let me turn the light off for you. Look right here. Right there in that area. You see that crack? There you go. So we know what that is. We have a cracked circuit board or circuit trace. We have voltage on the pin, but we don't have any voltage, so we're not supplying the VCO with any voltage whatsoever. So we see, can't we get this fixed? Alright, so what I'm going to do is reflow that joint. I'm going to get all of that old solder off first and reflow it and put some fresh solder on it. And never fails, telephone wants to ring. Alright, sorry about that. Let me reflux this thing. And don't be scared to use flux. Alrighty. Okay, I got a external speaker, antenna connector, microphone plugged in. Let's turn the radio on. So we have static. Turn it down a little bit. And all I'm going to do, not even going to bother about hooking the single generator to it. We're just going to key the mic on another radio. Check 1, 2. So the radio does appear to be receiving. Let's see if we get a red light on the transmitter. And we do. Okay, we'll look at the watt meter, see if we have any power out whatsoever. And it's keying about 1 3/4 watts. Test 1 2. Testing 1 2. 1 2 3. Testing 1 2. And that sure is a ugly sight. Not that it's not putting out power, but it's what I'm seeing on the scope in the spectrum analyzer. Okay, y'all have to roll with me because the spectrum analyzer is kind of pointed up and the scope is laying flat. I do need to get them where both of them are over top of each other and make the screenshot a lot better to be able to see them. But when I key the microphone, Let's go ahead and just look at the spectrum analyzer right to start with. You can see just now pay that spike on the far left no mind. I'm on a kind of narrow, so I narrow it up a little more. But you can see right over here is all 54 megahertz single. But I'll widen out on this right here, and you can see the two side bands on either side of the main carrier. But look at all these other spikes up and down here. I'm going to look at the 54 megahertz single. It's not too awful bad. Now you do got to know we're going through about 40 dB of attenuation, because I don't want any power at all getting into this spectrum analyzer. But still, it's not looking that good. And the reason why the spike is so high, you know, I told you that that one core has been spread apart like an accordion. And that is the result of that. So I want to show you what happens when you remove the limiters in the radio and you go stretching coils and mistuning the transmitter. Now, you've probably seen this setup many times on other videos where people are doing this, but I use a different way. You know, I demodulate the audio and I ride the audio onto the single. So if I turn the tone generator off, we look at over at the radio, you'll see there's a plug in it with an audio cable, and there's a PTT switch. And I know y'all seen it before. Up here is a box that's marked Y and X, and this goes to the Y and X mode on the oscilloscope. And what that box does is allows the carrier, so if I key the radio up, we can see a carrier, and you can see the unmodulated audio riding on top of the carrier. So I'm going to turn the tone generator on and let you see what this single looks like. And you can see that is just garbage. It is not defined in any way. And it kind of beats your 4-to-1 ratio. So anyway, there you have it, my friends. A $5 radio will work. Now, you know, the next thing that you would want to do to a radio like this is just go through and do your basic tune-up and alignment and replace the missing limiters and straighten the coils back out like they're supposed to be. But still, you know, these radios produce harmonics. Now, you can do a lot of work to them and get that out. But, you know, I'm not going to do that to this radio. Probably the next one I'll go through, we'll go through a Cobra 29, a good radio that you can follow along. Plenty of information on the net about it. But I just wanted to give you you know, a straight up what to do with a radio that doesn't work at all. Anyway, I hope you enjoyed this little video. If you do, you can always let me know by giving me a thumbs up, and I'll leave a link down below to the website. If you want to discuss this, you can go over to the website and do so, or you can leave your comments down below. Either way. Anyway, thanks for watching, and we'll catch you next time.